Chapter 4.1, Antiderivatives and Indefinite Integrations, or Indefinite Integrals. Find the general solution of the differential equation y prime equals 2. In other words, what function has a derivative of 2? All right, well, one function that has a derivative of 2 is 2x. Another function that has a derivative of 2 is y equals 2x plus 1. Another function, y equals 2x plus 2. There's an infinite amount of solutions to the differential y prime equals 2. And we write those y equals, since they all have 2x, we're going to write 2x, but they all have a different number added, so we say 2x plus c, which stands for a constant. So the general solution to y prime equals 2 is y equals 2x plus c, where c can be any constant. Now, how we solve a differential equation of the form dy dx equals f of x, this is kind of going to go through the symbolism of it. The symbol for working a differential, which is doing the antiderivative, you have the derivative and you're working backwards, that's why it's called antiderivative. The symbolism is we're going to use this, kind of a funny looking S. So we're going to take the antiderivative of dy dx with respect to x equals the antiderivative of whatever our function is with respect to x. Here, the antiderivative of the derivative is the function, so y equals the antiderivative of f of x with respect to x. That is what you're going to see. Right here is what you're going to see when the question is asking you, take the antiderivative of it. What function has this derivative is what they're asking when you see that symbolism. And we got a lot of basic functions we already know. Basically, you're starting with your answer. So, what function has a derivative of 0? Well, a constant has a derivative of 0. Instead of seeing it like this, you're going to see it like this. The derivative of a constant is 0. The antiderivative of 0 is a constant. Okay? The derivative of k times x is k. The antiderivative of k is k times x, plus a constant. Don't forget that constant. Very important, because you got infinite amount of solutions. You need to show that with plus a constant. The antiderivative of a constant times a function is a constant times the derivative of the function. Conversely, the antiderivative of constant times a function is the constant times the antiderivative of the function. So all the rules you've learned for differentiation are the same, except backwards. Well, most of the rules. Right? There is no product rule or quotient rule for antidifferentiation. Okay? When you're adding inside of the antiderivative, you can break it up into adding two separate antiderivatives. All right? Power rule, you subtract. Well, the antiderivative of the power rule, you add. Right? Everything's backwards. Here you multiply by the power. Here you divide by one more than the power. Everything's backwards. Just make sure your power doesn't start at -1, because you can't divide by -1 plus 1, which is 0. All right? Sine, cosine, same thing. And all the other trig functions hold up. So let's look at a few examples. First off, describe the antiderivatives of 3x. Right? So writing this out properly, we'll have the antiderivative of 3x with respect to x. That is going to be the power rule. The power here is 1. So working the power rule backwards, we'll add 1 to it. So it'll be x squared, and then we'll divide by the new power. So it's 3x squared over 2 plus a constant. And it's the power rule backwards. All right. Like all other derivatives, or like all derivatives, it's easiest to rewrite it as an exponent instead of doing fractions or radicals. So we rewrite 1 over x cubed to x to the negative 3 and use the power rule. All right, when we do that, we power up to negative 2 and divide by negative 2 plus a constant. For radicals, we rewrite the square root of x as x to the 1/2. And then we'll power up to 3/2 and divide by 2/3. Remember divide by 3/2, but remember dividing by 3/2 is the same as multiplying by the reciprocal. So we flip it. 2/3 x to the 3/2 plus a constant. And then for sine, if there's any multiple, we'll bring it out. Then what function has sine as its derivative? Well, negative cosine. Because remember, the derivative of a co is negative. Working that backwards, the derivative of a non-co, or the antiderivative of a non-co, is negative. Right? What's the antiderivative of dx? Well, the number hidden there is 1. Antiderivative of 1 dx. It's a constant. What has a constant as a derivative? X does. This would be x plus c. For option C here, what we want to do is split it into 3 antiderivatives. So we're going to do the antiderivative of 3x to the 4th with respect to x minus, and we could really pull that 3 out. It actually doesn't make it any easier, so I'm going to leave it there. Antiderivative of 5x squared, and again, you can pull the 5 out with respect to x, plus the antiderivative of x with respect to x. And these are all power rules, so we're going to power up. So the 4 will go to 5, and then we divide by the 5. So 3/5 x to the 5th. The 2 in the second one will go up to 3, and we'll divide by 3. And then the 1, which you don't write, goes up to 2, and you divide by 2, plus a constant. Now you could write a constant for every single one of these. However, that's three constants we don't know. Let's combine those into one constant we don't know, add them all up to be just plus c. All right? Like when taking the derivative, if you have a fraction, a 2-on-1 fraction, it's easiest to split it into 2 fractions. So we can rewrite this as x over x to the 1/2 plus 1 over x to the 1/2. Again, rewriting the radical as a fractional exponent. Here, we got x to the 1st over x to the 1/2. We'll subtract those. We'll get x to the 1/2 with respect to x plus the antiderivative of x to the negative 1/2 with respect to x. And we'll do all those antiderivatives. 1/2 powers up. We add 1 to it. We get 3/2. Divide by 3/2, which is the same as multiplying by the reciprocal. Plus negative 1/2 powers up. You add 1. That becomes positive 1/2. And divide by 1/2 or multiply by 2. Plus a constant. So all we're looking at is what function has this as its derivative. And we're going to have to use the rules we've used before. Split, rewrite. We want all powers to be in fractional or negative form, not to have radicals or fractions with polynomials. All right? Now, we've been finding general solutions. General solution is with the plus c because there's infinite amount of solutions. We're going to look at now is particular solutions. particular solutions. Those are solutions where we want to get rid of the c. In order to get rid of the c, you need to know a little bit more information, an initial condition. So we're going to start by finding a general solution. So we're going to find the antiderivative of 1 over x squared. We'll rewrite that right away. X to the negative 2. We'll power up. Negative 2 becomes negative 1, and then we'll divide by negative 1, which is the same as multiplied by negative 1. So our function is y equals negative 1 over x plus c. Now our initial condition allows us to find that c. What this is saying, f of 1 equals 0. Let's say x equals 1, y equals 0. So we plug those in. Plug those in for x and y, and that'll allow you to find c. So in this case, c equals 1. So our particular solution after we solve for c is y equals negative 1 over x plus 1. Here's the story problem we'll solve through finding the general solution and then the particular solution. A ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet, as shown in figure 4.4. All right? Acceleration due to gravity is negative 32. We'll take the antiderivative of acceleration to find position. So the antiderivative of negative 32 with respect to t is negative 32t plus c. Our initial velocity is 64. So our velocity at 0 is 64. That means negative 32t plus 64. The antiderivative of velocity is position. So the antiderivative of negative 32t plus 64 is negative 16t squared plus 64t plus a constant is our position. Our initial position is 80, so our position function is negative 16t squared plus 64t plus 80. And we want to know when the ball hit the ground. So we'll set this equal to 0 and solve for t. Negative 16t squared plus 64t plus 80. It looks like everything's a multiple of negative 16, so divide negative 16 out. We get t squared minus 4t minus 5. Use whichever method is easiest for you to solve that. I'm going to factor it. So we'll have t minus 5, t plus 1. And so the ball hits the ground when t equals 5 or t equals negative 1. However, the ball cannot hit the ground before you throw it. So I'm going to get rid of negative 1. The ball hits the ground after 5 seconds. So in review, y prime equals f of x. To solve for y, we're going to take the antiderivative. And there are infinite solutions to this. So what we're going to do to get the infinite solutions is we're going to find what function has a derivative of f of x, and we're going to add a constant.